In Chapter 5, we looked at arithmetic sequences, which had a consecutive common difference. In a geometric sequence, we have a similar relationship, only there's a common ratio between the consecutive terms. Each term is found by multiplying the common ratio by the previous term. So, for example, in this sequence 1, 5, 25, 125, the ratio is 5 because every time you add a term, you're multiplying by 5. Pause the video and try example 1. In letter A, our ratio is 3, so those are my 3 terms. In letter B, the ratio was negative 1/2. I multiplied every term by negative 1/2. When you're ready for example 2, let's look at graphing a geometric sequence. And I'll keep myself in the first quadrant because you can't have a negative term. And when I look at all the terms, they're already positive. So this would be position number, and this would be A sub n, which is my term. I have to figure out what the scale should be. It looks like I can go by 4s. So I'll do that, and here I'll go by 1s. So let's graph it. Now, before you go and connect it, remember, we're talking about a sequence. So remember from chapter 5, sequences are discrete functions. So we are not going to connect the points. But speaking of the points, what do you notice about the points? And you should notice that the points make an exponential curve. All right, let's move right along. You may remember my sequence table from arithmetic sequences. We're going to use the same kind of thing for geometric sequences, only instead of having a common difference, we now have a common ratio. So let's use a sequence. I'll just come up with one. 3, 6, 12, 24, 48, etc. All right, so first position, remember we call that A sub 1, and written using A sub 1 and R, well, there's no R yet, because I'm just talking about A sub 1, and in the numbers case, that would be 3. Position 2 is A sub 2. That would be A sub 1 times the ratio. So the ratio is, as you can probably figure it out, the ratio is 2. So that would be 3 times 2, which is 6. Third position is A sub 3. That's A sub 1 times the ratio squared, because that would be 3 times 2 squared, which will be 3 times 4, so that gives you 12. Let's check out the next one. A sub 4 is going to be A sub 1 times the ratio to the third power, which in our numbers case would be 3 times 2 to the third, because 2 to the third would be 8, and times 3 would be 24, etc., etc. So A sub n is what? Well, if you remember that when you don't see an exponent, you put a 1, and you think back to arithmetic sequences, the exponent in this case is 1 fewer then the position that you're talking about. So that would be a sub n times the ratio to the n minus 1 power. So I've got that listed right here, so that way we can just talk about the parts, and I hope you recognize the similarity between that formula and the y equals ab to the x generic formula. So a sub n is the nth term. That phrase should not sound foreign to you. It should sound familiar from arithmetic sequences. A sub 1 is the first term. R would be my common ratio. And n is the position that you're talking about, the position or the term number that you're being asked to find. So let's see this in an example. The first thing that we have to do, clicking the zoom out button on a mapping website doubles the side length of a square map. Write an equation for the nth term. So I'm going to use my generic formula, but instead of A1, I'll put what the first term is, which in this case is 5. And they tell me up here what the ratio is, but you can also check in the table. This is being multiplied by 2. So 2 to the n minus 1. Find and interpret a sub 8. Well, that would be the 8th term, or in this case, the 8th click. So a sub 8 equals 5 times 2 to the 8 minus 1. And now all you have to do is evaluate that. A sub 8 equals 5 times 2 to the 7th. Well, I got to get my calculator out to find 2 to the 7th. And that's 128. Oh, whoops, I forgot the 5. Times 5 is 640. So it'll be 640 is the 8th term. Now I have to explain what it means. So after 8 clicks, the map side length is 640 miles. After how many clicks on the zoom out button is the side length 2,560 miles. So now they're giving me the value that would go in this A spot, or A sub n. So instead of AN, I'll write 2,560. And now I have to solve for n. So divide by 5. And that's 512. Now, you can use guess and check to figure out what n is, but I'm going to use a skill that we learned in an earlier lesson. I'm going to rewrite 512 as 2 to the 9th. I'm going to make them have the same base, and then when they have the same base, you can make the exponents equal to each other. So that means that 9 equals n minus 1, so n is 10 clicks. And again, you could have used guess and check, but I'm going to use the skill that we learned earlier this chapter. If you have any questions, write them down and ask me when you come to class.